Now let's select this code section here and let's execute it to see if we have an optimal number of clusters. And yes, we do. We can clearly see that the point here is the elbow, and when we project this point on the x-axis, we obtain 5 clusters. So that means that the optimal number of clusters for our problem is 5 clusters. And thanks to this insightful information, we are ready to move on to the next step. Because the next step is actually to fit k-means to the MAL dataset with the right number of clusters, 5 clusters. So let's introduce this new step with the comment applying k-means to the MAL dataset. Then let's set a seed so that we all obtain the same results. We can pick any number, let's pick 29, and then let's fit k-means to our data x. So we create the object k-means from the class k-means, and then let's select k-means here and press F1. The first argument we have to input is our data x, then the second argument is the number of clusters, and now we know it's 5. And then like in Python, we can specify a maximum of iterations. Let's use the same value, itermax equals 300. And we can also specify the number of initial random sets, and start equals 10. Alright, now we have everything we need and we are ready to select this code section and execute it to fit the k-means algorithm to our data x. Here we go, and perfect. Now let's move on to the next step and let's get all the fun. Indeed, this is the fun part because we did our job fitting the k-means algorithm to our data x, and now we look forward to seeing the results. So let's immediately introduce this new section, visualizing the clusters. We are going to plot our clusters using the cluster library. So first thing we do is to import the cluster library, and to do this you can either go to packages and select cluster here, or we can type here library and in parentheses cluster, which is a better way if you want to execute later the whole script. And now let's plot our clusters. To do this, we will use clustplot. Let's select clustplot here and press F1 to see the parameters to input. So the first parameter is our data x. For the second parameter, we input the vector of clusters, that is, the vector that returns for each observation which cluster it belongs to. And we can take this vector by typing k-means $cluster. Then a parameter that we have to specify is lines. Because when you don't give a value to lines, some distance lines between the clusters will appear on your plot. And we don't really want that. So we're going to choose the value 0 so that no distance lines will appear on our plot. Then let's set the parameter shade to true so that the clusters are shaded with respect to their density. Then same for color, let's set it to true. Then we have the parameter labels, and we're going to pick labels equals 2 so that we have all points and clusters labeled in the plot. Then we don't really want different symbols for the points in different clusters, so we set plot car to false. Then we have this cool parameter span that allows us to plot ellipses around the clusters, and in order to plot the ellipses, we will set it to true. And finally, we would like to add a title to our plot, so we write main equals paste clusters of clients. Then we want to give a name to our x-axis, so we add xlab equals annual income. And same for the y-axis, ylab equals spending score. And now, moment of truth, let's find out what our 5 clusters look like. We select this code section here, and let's press Command or Control plus Enter to execute. Voila, our 5 final clusters. So let's look at them one by one. Cluster 1. Clients in Cluster 1 have high income and low spending score. So in this cluster, clients earn a high income but don't spend much money. So we could call this cluster of clients Careful, for careful clients. Cluster 2. Clients in Cluster 2 have average income and average spending score. So let's call this cluster of clients Standard. Cluster 3. High income and high spending score. So that is the cluster of clients that would be the main potential target of the mall marketing campaigns, and so it would be very insightful for the mall to understand what kind of products are bought by the clients in this cluster. So eventually we can give to this cluster the following name, Targets. Cluster 4. Low income and low spending score. So as opposed to the careless clients who have low income and spend much, we are going to call them the sensible clients. And eventually cluster 5, low income but high spending score. So clients in this cluster earn a low income but don't care and spend much. So let's call this cluster of clients Careless. Alright, we are done with the k-means algorithm in R. Look at our code, it's structured, simple, and it does the job perfectly well. And you can use this code anytime you want for your work, you just have to replace the name of the dataset, change the indexes of the columns of interest, and then you just have to execute this code to find some answers of your business problem. And if you are doing clustering in more than 2 dimensions, then don't execute the last code section to visualize the clusters, because it's only for 2-dimensional clustering. However, later in this course, we will learn a technique that allows us to reduce the dimensions of our dataset. So if you reduce your dataset to 2 dimensions, then you can use this last code section to plot the clusters. And now to finish this tutorial, let's clear everything. So we click on this button here. Let's also go here and press Ctrl L to clear the console. We select the whole code, execute it, and we make sure everything works fine. Thank you for watching this video, and I look forward to seeing you in the next tutorial.